equation of the hyperbolic function is f of x equal to a over x plus q. Now, there are two constants that are very important in the equation. The first one is this a here. Okay? That a, it tells you in which quadrants, okay, are you supposed to draw the two curves of the hyperbolic graph. Okay? A hyperbolic graph has got two curves. Okay, so far you've only dealt with graphs that are drawn as ones only. Now the hyperbola, you draw the graphs as in twos. So you draw two curves, but it is called the same graph. Okay, so this A tells you in which position in terms of the quadrants. Don't worry, I'll tell you what quadrants are. Okay, so those quadrants, there are four of them. Okay, so the position where you put the two curves is determined by the value of A in terms of its sign. If it's positive, you draw it in two different positions. If negative, the other two positions. I'll talk about that just now. So the A determines the quadrants in which you draw the two curves. Then the Q is the value of Y along what is called a horizontal asymptote. Okay, the hyperbola has got two asymptotes, a vertical asymptote and a horizontal asymptote. Again, this is a new word, so I'm going to explain what it is. Okay, so you've got two new terms, quadrants and asymptote. But if your grade 9 teacher had taught you the function in the straight line, maybe they could have mentioned the concept of quadrants. But if they didn't, then don't worry, I'll talk about it just now. Okay, now your Cartesian plane can be divided into four equal parts. So when you draw your x, your y-axis and your x-axis, okay, the area inside those two, okay, can be divided into four equal parts. And each part has got a number that is given to it. So we've got quadrant 1, quadrant 2, quadrant 3, quadrant 4. And when you give them names based on their numbers, you start from the first quadrant in an anti-clockwise direction. Okay? So the Cartesian plane is divided into four quadrants. Okay? The Cartesian plane is divided into four quadrants. Okay? Let me move on to the next page. Don't worry if you're behind, you can catch up because I'll send the PDF. That's why I requested you to log on online. Please, if you don't have. All right. Okay. Let me carry on. All right. So your quadrants, they are named like this. The area between the positive y-axis and the positive x-axis is called quadrant 1, or the first quadrant. The area between the positive y-axis and the negative x-axis is called quadrant 2. The area between the negative x-axis and the negative y-axis is called quadrant 3. The area between the negative y-axis and the positive x-axis is called quadrant 4. So you've got four quadrants and they are fixed. You cannot change those numbers. Okay, in this subject, you need to memorize and know where quadrant 1 is, quadrant 2 is, quadrant 3 is, and quadrant 4 is from now on. Okay, because the concept of quadrants is very important, not only for functions and graphs. Later, when you do trigonometry, you are going to need that knowledge. Okay, so make sure you are aware of the four quadrants. Okay, now when it comes to a hyperbola, when you draw it, one curve can be in the first quadrant, another one in the third. Or you can have in the second and the fourth quadrant. Okay, so you draw the two curves in numbers that are both odd or both even. Okay, so 2 and 4 are related, 1 and 3 are related. Okay, then let's move on to an asymptote. Now, an asymptote is a straight line that is approached by a graph, but it is never touched by the graph. Okay, it is a straight line that is approached by a graph, but it is never touched by the graph. So, if you have, say, your x and y axis like this, If I draw my y-axis, then my x-axis, okay? If I want to draw if I want to draw a curve or a graph, if I draw it closer to the y-axis and closer to the x-axis like that, it means my two axes, that is the x-axis and the y-axis, are asymptotes. Okay, which means they are both approached by the graph, but the graph will never touch them. So an asymptote is a straight line. It has got an equation. Okay, it is never touched by a graph, but it is approached as close as possible by the graph. The graph will get closer and closer to it, but it will never touch it. Okay? An asymptote is a straight line.
The x and y axis is the asymptote.
This is the curve. Okay? A straight line, or rather an asymptote, is a straight line. Pay attention. An asymptote is a straight line. Your two axes, that is your x-axis and your y-axis, can be asymptotes. Okay? If the x-axis or the y-axis are asymptotes, we draw solid lines like this. But if the asymptote is not the x-axis or the y-axis, then we use dashes to draw it, to distinguish it from the y-axis and the x-axis. Okay? Don't worry. If you don't get it now, later when I do examples, you will get it. Okay. According to that, it is the numerator of this fraction part. That's the a. So if a is greater than 0, which means a is positive, and if we consider q to be positive, to be 0, when you draw the hyperbola, as long as a is positive, the first curve will be in the first quadrant, and the second curve will be in the third quadrant. That is only if a is positive, which means a is greater than 0. Okay? So your q is 0. Now, when you say q is 0, it means we are saying the value of y along the horizontal asymptote is equal to 0. Okay? And maybe you didn't know, but from now on you must know this. The y-axis has an equation. The x-axis has an equation. The equation of the x-axis is y equal to 0. Okay? The equation of the x-axis is y equal to 0. So for this case here, that is case 1, your x-axis is an asymptote. Okay? That's why when you sketch it, it will never, the curve will never touch the x-axis. Also, the y-axis is an asymptote, and the equation of the y-axis is x equal to 0. Okay? You can get a question asking you to write down the equation of an asymptote. That's a very common question until you write metric. Okay? And the foundation is laid now. Right, so that's the first case. Then case 2, we are going to keep the a positive. Okay? Let me use which color can we use from there? Right? So we'll keep the a positive, which means the shape is gonna remain in terms of where you draw the two curves gonna be exactly as the first one. But we are gonna make the q positive. Which means q is no longer 0. Remember, q is a y value. I need to emphasize that. Q is a y value. So you never find q on the x-axis. Q will always be on the y-axis. Q is a y value. So if I say my q is here, okay, then I have to draw an asymptote passing through point Q. So this line which is in green, that's my asymptote. And it has got an equation. Okay, I'll talk about the equations of asymptotes later on, because for now I don't want to confuse anybody. For now, let's deal with the shape. Okay, so you draw a line passing through y equal to q. Q is a value of y. Q is a value of Y. Okay? So what this means is my horizontal asymptote is going to be above the x-axis. The Q also tells you that there was vertical shift. Okay? There was vertical shift of A over X. So if you move Y equal to A over X by Q units up, you end up getting a new equation which will be A over X plus Q. Okay? So there's more than one meaning for the Q. For now, the main one is that Q is a Y value. Okay? So this is case 2. Let's move on to case 3. Now, case 3, we are going to keep the A positive, but we'll make the Y or the Q negative. Okay? So let's move on to case 3. So for case 3, the A is still positive, the Q is now negative. Okay? Which means when you draw our two curves, they are going to be in the first quadrant and the third quadrant. So I'm going to have, first thing, since Q is now less than 0, I need to indicate where my Q is. My Q is now below the x-axis. So I can say this is where my Q is. Then I can draw an asymptote. Okay? I can draw an asymptote passing through the point where Y is Q. Now, once I draw the horizontal asymptote, okay? Can you look at me, please? Once you draw the horizontal asymptote, that horizontal asymptote will now seem like your new x-axis in quotes. When you draw the horizontal asymptote, it's more like you need to neglect the original x-axis. So this asymptote here, it will now behave like a new x-axis. So your first quadrant here is going to be the area between the y-axis, including the negative part of it, and the positive side of the x values of the asymptote. So this area here, okay, let me use another color, that one. So the area between the y-axis and the positive side of the x values of the asymptote, that will become your first quadrant. Your second quadrant is going to be this area here between the y-axis and the negative side of the x values of the asymptote. When I say negative values, I'm referring to negative values of x. Then your third quadrant is going to be between the part of the asymptote which has got negative x values and the y-axis. Your fourth quadrant, y-axis, they are all negative, and the positive side of x values of the horizontal asymptote. Okay? So when you draw the horizontal asymptote, it will now seem like it's your new x-axis. Okay? So when I draw my two curves, right? The first one, I have to draw it like that, which means I must have an x-intercept here. Okay? It is possible when you draw a hyperbolic function or the graph of a hyperbolic function to have an x-intercept. And on the other side, there is no x-intercept. So it will have an x-intercept here, but no y-intercept. So the y-intercept will be undefined. That's very much possible. So that's case 3. Then case 4. Case 4, we are going to change now the sign of A from being positive to negative. So A is now negative, and Q, we are going to make it equal to 0. Okay? So if we do that, when you draw it, Okay? Because A is now negative, the first curve will be in the second quadrant. Okay? And the second one will be in the fourth quadrant. Okay? Please take note that these two curves don't touch both the x and y axis if q is 0. Okay? So your shape will look like this. Q is 0, which means the value of y here is 0. Okay? And your x-axis will be the horizontal asymptote. Let's move on to case 5. Because I need to probably finish all the properties. Or at least most of them I need to talk about them too. Case 5. Now case 5, we are going to keep A negative. So A will be negative, but we are going to make Q positive. Okay? Now if Q is positive, means Q is above the x-axis. So we can have our Q somewhere there. And then when I draw the asymptote, please always draw your asymptote first before the curves. Because the asymptote will help you to know where to draw the two curves. Right? So you have got your horizontal asymptote, right? Since A is negative, it means the first curve will be in the second quadrant. The second curve will be, now look here. The second curve will be in the second quadrant, our fourth quadrant. Our fourth quadrant is going to be that one there. Okay? Which means we can have an x-intercept. Alright? Alright, I will tell you something that's very important when I finish case 6. Right? Then, case 6, we are going to keep the A negative, but the Q is now negative. So when you have got that, your graph must look like this. Our Q is now negative, so it's below the y-axis. Sorry, below the x-axis. So if I draw the asymptote, it will be like that. So my two curves, one will be in the second quadrant, the other one will be in the fourth quadrant. Okay? So, in this grade, if you are given any question on the hyperbola in terms of the graph, you are going to encounter any one of the 6 graphs that I just drew. Any one of the 6. Okay? The shape is going to look like any one of the 6 that I just told you about. Okay? Now, there are some limitations in grade 10. As I told you in the previous lesson, that there is no horizontal shift in grade 10. There is no horizontal shift of a graph in grade 10. We only deal with vertical shift. That's why if you look at all the 6 cases, we don't have a y-intercept. So I want you to write below these 6 graphs, just write NB, okay, in the margin or wherever, but write it down somewhere. I'm going to dictate it, I won't write it down. NB, all hyperbolic graphs, please write that down. All hyperbolic graphs in grade 10, all hyperbolic graphs in grade 10 do not have a y-intercept. all hyperbolic graphs in grade 10 do not have a y-intercept. Because, I'll give you the reason, because the y-axis is an asymptote. All hyperbolic graphs in grade 10 do not have a y-intercept because the y-axis is an asymptote. Okay? Then you put a full stop. Right? That's in grade 10. So, whenever you are sketching, you are only going to determine the x-intercept if it exists. Okay? But you never get the y-intercept. So if you substitute x equal to 0 into the equation, you will never get a value for y. Your calculator will tell you that it's undefined because of the existence of the asymptote. Okay? So make sure you are aware of it. So that's the shape. Okay? Let's move on to equations of asymptote. Equations of asymptote. Number 2. Equations of asymptotes. Right? I've already told you that the x-axis can be an asymptote. The y-axis can be an asymptote. Okay? Now, any hyperbolic graph has got two asymptotes. Okay? The first one, okay, I'll call it A. Remember, we are talking about the equation. Okay? So, the equation of vertical asymptote. Equation of vertical asymptote. The equation, it's an equation. Okay, I need to emphasize this because I've seen all sorts of things. Since I am your teacher, but I'm gonna tell you now, you need to know it until metric. Okay, any metric paper has got the hyperbolic graph. When is it first taught? Grade 10. Your vertical asymptote is the y-axis, but the y-axis has an equation. So the equation is always x equal to 0. Okay, let me use a different color just to emphasize it. Because this part here, some of you, I hope that you won't let me down from now on. The equation of the vertical asymptote is x equal to 0. X equal to 0 is the y-axis. The y-axis is a line. The y-axis is a straight line. So it has got an equation. And the equation is x equal to 0. So if you get a question asking you, write down the equation of the vertical asymptote, your answer is x equal to 0. Always. You don't have to think about it. Okay? Then, equation of horizontal asymptote. And please take note. This word here, it means your answer, if you get a question asking to write down the equation of an asymptote, it must start with x and it must have an equal sign. Or it must start with y and it must have an equal sign. Okay? So, the equation of the horizontal asymptote, it is written in terms of y. So, it's y equal to q. Okay? It's y equal to q. For now, don't worry about the q. But remember, the general form is f of x equal to a over x plus q. So what I mean by y equal to q, it means when you are given the equation of the hyperbolic function, whatever value of q will be here, that's the value that you put here together with the sign. So if q is negative, then you also put a q which is negative. Like for example, if I give you a function, say y equal to 2 over x plus 1, it means q is 1. Okay, pay attention. It means q is 1. Therefore, the equation of the horizontal asymptote will be y equal to 1. Okay, so whatever value you have here, that's the one that you put there. Okay, and you need to remember always that your horizontal asymptote is y equal to q. Your vertical asymptote is x. Sorry, the equation of the vertical asymptote is x equal to 0. The equation of the horizontal asymptote is y equal to q. I don't want to see anything else. If you get a question on the asymptote in terms of the equation, if you write anything else, I'll give you a hiding. Okay? Right, let's move on to the axis of symmetry. The graph has got two axes of symmetry, and the axes of symmetry are equations. So number 3. Equations of axes of symmetry. Equations of axes of symmetry. Any hyperbolic graph has got two axes of symmetry, and the two axes of symmetry are straight lines. Okay? And they have equations. Since they are straight lines, they have got equations. That's why you need to be a master of the straight line. You need to be a master of the straight line for you to understand all the grade 10 graphs that are new to you. If you don't understand the straight line, you have challenges. Because the straight line is the foundation. It's like this room here. When it was built, there was a foundation which was laid. The straight line is the foundation of all the graphs that you are going to encounter. Okay? So, the equations of axes of symmetry, it's like this. If I draw a sketch, don't worry, we'll write them down just now. But I just need to make sure that you are aware of this. So, if I have a function like, say, f of x equal to 2 over x. So let me not put 2, let me put 1 over x. Because that's the basic one. Right? When I sketch it, one part will be in the first quadrant, the other part will be in the third quadrant, because the numerator, okay, of this fraction part, that's your a, based on the general form, is positive. So when you sketch it, it will be in the first quadrant, third quadrant. Now, there are axes of symmetry. The axes of symmetry, they are straight lines, so you can draw them like that. And the other one, let me use that one. You can draw it like that. Okay? Just give you an example, right? I hope in grade 9 you know that the equation of this line is y equal to minus x. And the equation of this one is y equal to x. Okay? These are basics of the straight line that you're supposed to be aware of. If a straight line passes through the origin, it means the y-intercept c is 0. Okay? So the equation of that, so this any hyperbolic graph has got two axes of symmetry. And the two axes of symmetry have got equations. So I'm gonna write, because I don't have enough space. In your book, you must write these equations down below this graph. So I'll give you the general equations. The general equations are 1, you have got y equal to y, the one with a positive gradient, it's y equal to x plus q. The one with a positive gradient. The one with a negative gradient, it's y equal to minus x plus q. Okay? These two are your equations of axes of symmetry. Okay? Where there is q here, you get that value from the original equation of the hyperbolic graph. Where there is q there, you get that value of q from the original hyperbolic equation. Okay? The coefficient of x here is positive, so the straight line is a positive gradient. Okay? The coefficient of x here is positive, so the straight line we have a what? A positive gradient. There is a minus here, means that line has a negative gradient. All right? Now, please do me a favor. You need to get to watch some of the videos on the straight line. I taught about the sketching, the determination of the equation of a straight line, and so on. Okay? And you also need to make sure that if you can manage, then subscribe to the YouTube channel so that if something happens to your videos or whichever the case, you always have access, because Google has got a huge cloud service. That's why they've got YouTube. Okay? So if you can, please also do that. Thank you so much to those of you who are on the YouTube channel. Right? Okay. So make sure today when you go home, you sit down. Some of the things that you have here, your textbook doesn't have them. Right? Make sure you sit down, you go over all the work. In the next lesson, we are going to start sketching. But for you to be able to sketch, know your properties. Know your properties. And I want you to be aware that as long as you are going to carry on with this subject until matric, the functions that you are doing now are extremely important. If you play around, like what I observe some of you doing, because when I'm standing in front of you, I can see who is serious and who is not. You are going to find this subject very challenging, because functions and graphs, it's a major topic. It contributes lots of marks in an examination up to matric. It's a very important topic, so take it serious. And those of you who are doing physical science, I told you that you need your knowledge of graphs. Okay. Later you are going to do what are called equations of motion. Equations of motion are equations of a straight line. So if you understand the straight line in physics, you are going to find your life easier. You are going to have a quadratic function in physics, but it will come as a different equation. Okay?